Good evening, everyone. How are you? Fantastic. What a great crowd we got. It's like standing room only. Only appropriate that I'm retiring in May, and this is my very last LabCorp Leadership and Technology talk. Only fitting we should go out in a bang, right? So to all you individuals who don't have seats, I think there are a smattering of seats. If you have an open seat, maybe raise your hand. There's 2, 3 out here. Yeah, there's a few. However, I will tell you that if you get tired of standing, you can sit. If you get tired of sitting over there, we are broadcasting this live. Okay, so you can link in through the link that's on the department homepage for the talk tonight. Okay. All right. I am Ken Tate. I am the Director of Engagement External Relations. It's my honor to welcome each of you here. This is the LabCorp Leadership and Technology Speaker Series. If you didn't know it, this has been in place now for 16 years. This is our 96th talk, and I have seen them all, okay? And I can tell you most of them have been very good, and I have really high expectations from our talk tonight. Before we get going, just a couple of important announcements. I mentioned that we're not only streaming this live, but we are recording it. So if you want to go back and watch it later on, if you know somebody who couldn't make it, they can go back and watch it later on. It normally takes 3 or 4 days for us to get that up and out there. Now would be a great time to turn off cell phones or any devices that might serve as a distraction. And I can tell you that since this series started 16 years ago, we have tried to cover all different types of aspects of computer science leadership or leadership in technology. And today we're going to be talking about business analytics, artificial intelligence, and we're very, very pleased to have with us a special guest speaker tonight, Sglavo. Udo is with SAS, has been with SAS for 25 years in a variety of leadership roles. And if you're wondering, why am I not hearing him through the speaker system? This is just for the external folks that we're streaming this out to. Udo is currently the Vice President of Applied AI and Modeling Research and Development at SAS, and his commitment to pursuing the boundaries of what AI can achieve has earned him recognition as a global thought leader, shaping the future of technology. He's written 3 publications, holds 4 patents in advanced analytics. Ladies and gentlemen, Udo Sglavo. Udo?
Thank you so much. Well, talking about high expectations, let's watch a video first, just set the scene. Is that working? Let's maybe not watch a video. Can you maybe hit the... May?
Data is everything. And now, everything is data. Taps, steps, beats, transactions, debits, credits, shipments, returns. Everything is data. And every day there's more of everything, which means more data, more information, more things to process, more things to analyze. And speed to answers matters more than ever. SAS Viya is faster, more productive AI and analytics from the people who first brought analytics to the masses. It speaks every kind of language, so you can bring your own. It cleans your data so you see things clearly. It shows proof so no one doubts your models. It lets you drag and drop knowledge and insight on people that need it. There's more information than there's ever been before. Tomorrow, there's going to be even more. And SAS Viya is the quickest way from a billion points of data to a point of view. SAS Viya, more productive AI and analytics.
Alrighty, so first of all, thank you so much for giving me the opportunity to talk to you tonight. I just came over from our campus, which is in Cary, North Carolina, for those of you who don't know where SAS is. It's a huge pleasure, and you know what I want to do tonight is basically give you a little bit of an update on how we as a company define ourselves in the market. Now, SAS has been around for almost 50 years. You know, this is a long, long lifespan for a technology company. For a software company, it's pretty much amazing. There are not many software companies out there who are in the same age range, maybe SAP, you know. So I wanted to provide you a little bit of an overview, and I also want to show you what we are currently working on. So not everything which I'm going to present tonight is production software, but some of it is research, which we are currently working on, just to give you a little bit of an insight on, you know, what is the team at SAS currently working on. Does that make sense? Let's get the most important question out of the way, sports. I hope you had a wonderful weekend, just like me. Germany beat France 2-0, right? That was pretty much good, and I heard you guys did well in the Sweet 16 as well, so congratulations to NC State. Talking about NC State, what you may not realize is that SAS was actually invented here on campus. You know, a couple of years ago, let's say, our founder, Jim Goodnight, Dr. Jim Goodnight, was a statistics professor at NC State. And so the roots of the software is really on this campus. Now, when they decided to create SAS as a company, they did an interesting move. They moved just across to Hillsborough Street. If you think about that, probably they liked the coffee so much on campus, so they could still access it. But you know, that was the first time SAS was basically created as an entity. That's in '76, so probably older than most of you are, right? So this is a picture of Dr. Goodnight holding the first SAS version in his hand. This is an abacus which he received when he was a member of the Apollo space program research team. And when they basically sent him away to make a fortune, they gave him this abacus. SAS is, in a way, still what we are seeing here. It's a huge calculation engine. But of course, technology has changed. You know, so we are not talking about people sitting there doing manual calculations. But these days, we are talking about cloud computing, of course, big topic, right? And we like to consider ourselves as a native data and AI company. And I'm going to define to you what this means, if that makes sense. So here is a little bit of background on the company. As you can see, you know, we've been quite successful with almost 3 billion of revenue. Half of the revenue is generated in the States. The other half is generated in Europe, Middle East and Africa and Asia Pacific. You can see that we are working almost with every industry which is covered here. Our main industries, though, are financial services like banking, insurances, but also government and life sciences. Those are the industry we make the most money with in these areas: machine learning, AI, data science, you name it. We have currently about 12,000 employees worldwide in 140 countries and about 70,000 customer sites. So now a customer site is basically an entity. You may have hundreds or thousands users in a customer site. So it easily adds up to hundreds of thousands of users. For research centers, I'm based in Cary, North Carolina. We have a research center in China, Beijing, and in India, in Pune, and in Europe, which is in Scotland. So this allows us to do development around the sun and basically pass on tasks to individual teams around the globe, which is quite exciting. But it's also interesting because you have to learn to work in such an environment. Communication is key. So if you ever wondered, what is a skill which I may want to train besides my graduation skills, it's communication skills. This is something which will benefit you on your journey through the job market quite a bit, particularly if you want to work in a global environment. And you need to learn about different cultures and how to cope with interests from different countries. In order to scale up, of course, we have a huge partner network. And this is what we are doing. So whenever somebody asks me for the elevator pitch, what is SAS working on, I usually talk about that. It's 3 major components we are delivering. One we like to call the technology platform. And I'm going to spend a little bit of time today to explain to you what the technology platform is. On top of that, we are also creating something which we call industry solutions. You can think about this as taking industry expertise into a software bundle and put it on top of a existing platform. So for example, we have a solution for fraud detection. Fraud detection is basically dealing with questions like, if you swipe a credit card somewhere around the world, is the transaction fraudulent, yes or no? And as you can imagine, these decisions need to be made in split seconds, so there can't be any delay, because you don't want to stand there for hours and hours waiting for the transaction to be approved, right? The third component is something which we are introducing only this year, which is called models. So I'm going to explain that throughout the presentation, but just in a nutshell, we have so much experience gained over the many years working with customers, solving individual customer problems, that we realized that there is value in just selling those models to the market as a lightweight offering. And that, of course, stands on the shoulders of things like large language models, foundational models. We realized that companies out there are now willing to buy those ready-made models instead of developing them themselves. Okay. Gen AI, huge topic in the entire industry. How can I not talk about this? And what you see around in the outer ring are basically the 3 pillars for R&D, which we basically like to ask our teams to consider when they develop software. Performance is almost a no-brainer. If somebody pays for software, you want to make sure that you get the best experience which you can have. Productivity is basically, and you may not like to hear this, but it's a reality. We are trying to take the computer science out of data science. So what does that mean, right? It basically means that a lot of our customers are not necessarily computer science savvy. They don't want to spend a lot of time combining packages and bringing offerings from different vendors together so they worked with each other through APIs. They want to have this, experience where you just say, I want to focus on my problem, not on the IT problems, right? And finally, trust. And trust is a big topic in the area of Gen AI, because people want to know, are the numbers, are the answers which I'm giving you, are they trustworthy? Or is the system hallucinating? You heard about that, right? That, when you talk to an LLM, it sometimes gives you strange answers, right? And the only reason from a mathematical point of view is, of course, that you are now in the area of a solution space where the model has not been trained on. So it starts to make up things. By the way, that also is true for numerical models. Regression. If you input a number into a regression model, which the regression model was not trained on, what happens? Well, the regression model will give you an answer, but it has no idea whether that answer is good or bad because it never has seen that number before. So it's also the concept of hallucination. Alrighty. By the way, internally, we call this the SAS donut. So if you talk to a SAS person, you can now say, hey, I know what the donut is. Right? Underlying that donut is a concept which we invented, I believe, 10 years ago, which we like to coin as the analytical life cycle. So what's the idea of the analytical life cycle? It basically says data science, analyzing data is not about building the model only, right? So you may be a top expert in creating decision tree models, large language models, neural networks, you name it. That's important, but if you want to put this into a business context, it's only one piece of an entire journey. And where does the journey typically start? Well, with accessing the data, right? If you can't get to the data, you can't have any models, you can't make any conclusions based on the outcome of the model. Now, data, which we tend to analyze, is particular. And what I mean by that is it's never created to be analyzed. And that's very different to the world of classical statistics, where people design experiments, for example. So they determine, if I want to develop a new drug, well, how do I roll out this drug to the market? You have to basically run through some tests. You have to think about, well, how many people do I have to feed that drug to figure out, is that drug helping, yes or no? And that's a very organized environment. The analyst is designing how the data will look like. Now, in reality, 95, 99% of the times, we are asked to analyze data which was never created to be analyzed. And what could this be? Well, let's go back to the fraud detection model. If I'm swiping a credit card, all I'm getting is machine data, right? It basically is information about the device where the card was swiped, and that's all I have, right? And now I need to determine from that data, well, is the transaction fraudulent, yes or no? Does that make sense? Awesome. Developing models, let's not spend too much time on that because you guys are all experts in that, I understand, but the models are useless if you can't put them into production. And this is what we call, I think the modern word for that is DevOps. Basically it's all about how do I take my math, which you found on your computer somewhere on your desk, and put it into the enterprise environment so that decision makers can basically access that math without knowing that it's actually advanced math. For them, it needs to work like your iPhone, right? It's almost like, when you want to get from A to B and you bring up your navigation system, your GPS, you don't need to know what kind of algorithm is running in the back to give you the shortest path. You just consume the information. And that's very true for most of our customers. They're ending on the side of the decision makers. So we like to believe that with our software, you become a better decision maker. And sometimes these decisions can be fully automated. Think again about the credit card swipe. There's no human involved, right? There's no human in the loop. Everything is through automation. Everything is through APIs. But for very important decisions, let's say, do I want to open a new store, in Cary, yes or no? That's a huge investment and I don't want to get that decision wrong. Well, it's better to have a human in the loop. So we are providing that decision maker with all the information we have, gained from the data which is available. So how do we do this? So we have spent a lot of time building what we call VIA for the enterprise. And while we were developing this, the big theme in the market was low code, no code. Have you heard about that? So it's all about drag and drop. People were getting tired to write code, interestingly enough. Right? So we started to develop a lot of graphical user interfaces which can be used without writing a single line of code. Now you can, of course, write code in these interfaces as well, right? But the dominant use case was really how can we enable people who are not Python coders, who are not SAS programmers, who are not R experts in these environments. Now, over time, the market has changed, right? So now, if you go out and you apply for a job, you will probably be asked, well, what are your coding skills? Honestly, I think this will change again, right? Because if you use a large language model to create code, it does a decent job today, and it probably will do a fantastic job in 5 years. So in your mind, you need to think about, well, what can't the large language model do? And that's design, right? Software design, software architecture, that will still remain important. Writing code, which you could do after your first semester at NC State, that will not be your task, will not be anybody's task. This will be done by copilots, right? That code will be generated automatically. But to design the environment, to make sure that the software is doing what we are intending it to do, though it follows the use cases, that's your task. And I don't believe that the LLMs will do a good job in the near future for that. So a lot of opportunity. But coming back to this environment, this is Workbench. Workbench is an environment which allows you to do coding, whether it's in SAS, which is a coding language, whether it's in Python, whether it's in open source R. So you basically bring up your favorite browser, you basically ask the system for a environment. It's all cloud-based, cloud-native. You tell the environment, well, how powerful do you want the environment to be? You spin it up for as long as you want it. Once you're done, you spin it down, no costs. Now, this is cloud computing at its best. And this is a theme which you're seeing across many companies, because they started to realize they made so much investment in hardware, and the hardware is sitting idle 50% of the time. Nobody's using it. So the investment is kind of questionable. Now the trend is towards pay for what you use, right? So you spin up the environment when you use them, you tear it down when you don't use them. And this environment allows you to do exactly that. And then on top of that, we are also developing a user interface development environment, which we call App Factory. But I want to show you how this all comes together. So you basically can connect the workbenches via the enterprise version. And then, this little cube is illustrating a model. So you created a model with your workbench. You're now deploying it in the enterprise system, and now the solutions can take advantage of that. Or you can go ahead and use App Factory to build your own interfaces and maybe use those interfaces to run the model. Oopsie. Let me just go back one more. So I promised you to talk about models as well. So the little cubes which you just saw, we want to sell this as a standalone entity. And let me show you why we are starting to do this. So what you are seeing here is a use case of a bank in the United Kingdom, where they are basically building a fraud detection system. Here it's about not credit cards, but debit cards, way more popular over there in Europe. And their own modeling team was building a fraud model themselves. But at some point in time, they hit a ceiling and they couldn't increase the accuracy of that model. So they called us up and said, hey, you as SAS, you've been working with so many banks. Can you come in and fine-tune the model for us? And we certainly did. And you see the numbers there, but that's not the point. The important point is that we started to realize that there's value in just selling those models to the market. And as this friendly gentleman is telling you, we have been doing this hundreds and thousands of times already. So what we are doing now is we are basically taking those use cases and combine it with software and sell it to the market as standalone offering. So here you go. So you have the models as an additional component. Does that make sense to you? Are you still with me? Awesome. I haven't talked about Gen AI, of course, right? And no presentation these days is complete without mentioning Gen AI. So I want to say what we are doing as a company to give our customers access to large language models. First thing I will say is that we will not build a large language model ourselves. We will consume what's out there in the market already, because those decisions are most of the time made by our customers already. You know, they made some agreement with, let's say, Microsoft, so they want to use the Microsoft OpenAI large language models, right? Other companies may be more working on an open source strategy where they're using open source code all the time, so they want to go with large language models which are available to the open source community. What we want to do is add business applications on top of that, and that is something you will find all across our offering. All right, so what we are going to work on is what people like to call co-pilots, and I'm going to show you an example of that in a second. But we are also going to release what is sometimes labeled as AI assistants. And AI assistants are really smart chatbots, right? So you basically have a chatbot-like interface. You can ask the chatbot questions, and the challenge which we have as a software engineering company is to create the prompts which the LLM will understand, and it can make sense of the questions the user is asking our software. So in a way, we have become prompt engineers ourselves. Okay, so what we have in mind is that, you know, if you spin up one of our assistants, you can ask the assistants, well, what can you tell me? And then the assistant will say, well, you can ask me these questions, right? So this will replace the experience how users will interact with software, I believe. So gone are the days of complex user interfaces, right? So we will still have user interfaces, of course. Graphical user interfaces will not go away, but you know, what we will find is that because of the breakthroughs in large language models, language will play a much higher role in interacting with software and computers. Okay? So let me give you some examples for what we are working on these days. First thing, has anybody coded in SAS before? Do you guys have any experience with that? Okay. How was your experience? No, don't say it. The good thing is that we will create a code generator for SAS users, right? So you can now basically say, write the code for me, right, as a starting point, which is kind of cool. And I want to show you a recording of one of my colleagues, John Lehrer, who used to be a lecturer at NC State, I understand, so maybe some of you will recognize him. But let's have a look at what John has to share here. And again, this is not working.
So I'm very excited to showcase some of the features we've been developing for SAS via Copilot. Here we have the Visual Studio Code editor. You may or may not be familiar with it. We have a basic data set we've loaded in. And here you can see the data set itself. It is a toy pharma data set. We have an ID variable, treatment group, an age at the time of study, time to event, and event occurred variables. And here we have a number of prompts that are written in normal human language, and we want SAS generated code based on those prompts. So in this case, I want to print the data set. I click anywhere in this SAS comment, and there's this option to generate code. I select generate code, and I get the ghost code option to use proc print. It looks good to me. I'm going to press tab and accept that code. Similarly, I want to start looking at the data maybe a little bit more. I want to understand, maybe what proportion of the observations were censored. So I want to do a frequency table on the occurred variable. Now here I just said on occurred, but the software is sophisticated enough to understand the context of the program it's looking at. So it identified that even though we used the word occurred, the variable itself is actually called event occurred. I can press tab, accept that code again. Next, I want to start visualizing, doing some basic exploratory data analysis. Again, I can click anywhere within this prompt, right? It automatically highlights the word. That's just a process of Visual Studio Code. But the point is that I'm in this prompt somewhere, and I get this option to generate code. As you can see, it uses proc sgplot to create a scatter plot that is grouped by event occurred. Now let's say we want to start doing some actual analytics. So we want to start estimating a survival function for this data. Once again, I click the option. And we're going to use proc life test. Now there is one thing that you have to be careful. So we always have to have, right now we're saying we have to have a human in the loop. One of the options that the code here that was generated automatically filled in for me was this value right here. So if you're familiar with how proc life test works, when there's a censoring variable, you have to let the program know what is an event and what is a censoring. So here it just assumed that the censoring, the event that we cared about was 1 and the censoring value is 0. Right? That's going to be based on the context of the software and the data itself. So you might want to change that and make sure that the developer who's using this has the context awareness to know which one is actually measuring an event occurring or a censoring. Finally, we can do a proportional hazard model. Now, in this case, we haven't had multiple generations. We have the tool itself supports multiple generations for these prompts. So I'm asking it to generate a prompt. I'm estimating a proportional hazard model based on this. On the right-hand side, you can see there's a little right and left arrow. It's just 1 out of 1. So right now, I'm doing this live. Sometimes it generates multiple responses. This time we lucked out, or maybe unlucked out, and only had 1 response we can generate. But it looks good to me. I'm going to accept it. And now I will run this code with very minimal intervention. It'll take a minute to connect to the SAS session. So when we developed this code, we developed it in partnership with Microsoft. So under the hood, right, we have a foundation model. In this case, we used Phi2, and we fine-tuned that model, right? So we have SAS documentation, we have technical notes, and we also have our own hand-curated examples that we used to build out the properties of this model to actually perform better than out-of-the-box GPT or other foundation models. So in this partnership, we're able to generate a better product that does a better job at a very narrow task, which is writing SAS code. And here, the code executed. We see that it printed the data set. We see that we have the frequency table. We see our plot. We see our life test tables. And if we keep scrolling, we'll eventually see our the survival analysis curves and the proportional hazard model. So I showed you one of the features that we are working on, which is the generating SAS code based on a prompt. But there's 2 more that I want to highlight as well. One is adding comments to existing SAS code. So I can select some code here. Let's select the plot code. If I select a portion of code, I'll get 2 new options that appear above. One is add comments and one is explain. We'll start with add comments. Now, right now, the add comments and the explain features are actually using GPT plus RAG under the hood. Right? So we have our retrieval augmented generation server that includes a similar corpus of data that we use for our fine-tuning. And then because we wanted this to leverage more of the conversational nature of these requests, we're currently using GPT underneath that. Now, the way we've built this, that can change over time. So we've built it to be flexible, that we can always sort of input the latest and greatest models underneath this to power this software. So here you see it describes how sgplot works. It describes the options that we used in a very useful way. Now, programmers love this because they hate writing comments. So when they see this, they get wowed. Some of the higher execs, they love the code generation because they see the cost of individual programmers typing everything out. Now, finally, I want to show the third feature, which is explaining code. So maybe I'm familiar with a Kaplan-Meier curve in general, but I don't know SAS code. I don't know proc life test. I can highlight that selection of code. I can select explain. And it'll pop up this new window on the left-hand side. Now, this has been collapsed so far, but it'll send this segment of code, once again, to our underlying LLM. And It'll take a little bit longer, as we know. One of the benefits of fine-tuning a smaller language model, Phi-2 is what Microsoft calls a small language model, is that they're more flexible, they're faster, and they can be fine-tuned for very specific tasks. So we saw it took a little bit longer, but we had this very nice, very verbose conversational explanation for what this code does. So once again, this is one of the first features we're developing within that SAS Viya Copilot suite. If you want to see some more of this in action, come see me or my colleague at the demo booth in the hallway.
So this was just an illustration of how the life of coders will change. We do the same thing, by the way, for Python and for R. As I mentioned, SAS is currently at a turning point, where in the past, if I would have done this presentation, let's say 5 years ago, I would have said, well, in order to code SAS, you need to learn SAS, the language. That's no longer true. If you are Python experts, you can code away in Python and access our engines behind the scenes. So we are basically doing this to, benefit the younger generation, of course, right? Pretty cool. So the second example I have is a real-world example. We've been working with Nestle. As you know, Nestle is one of the largest consumer packaged goods company. So they do a lot of the food you're purchasing in your grocery shopping. And what they wanted to do is to solve a very specific business question, which is related to inventory. So basically imagine a truck driver arrives in the morning at the gate of the Nestle facility delivering goods. So Nestle has different inventory storage rooms. So the truck driver wants to know, well, where should I go, right? Now this is, of course, dependent on what kind of goods does he have. Is it something which I need in the production line very frequently? Is it something which I'm needing maybe once a month, once a quarter? And also, what is the space requirements of these products? So in the past, that would have been a longer discussion with an inventory analyst. So what we have done is basically we created a chatbot. And so now the truck driver will be able to talk. I'm using the type-in version here, but of course, with speech-to-text, this is not a big miracle. The truck driver will be able to talk to a large language model and ask, where should I go? And the large language model will run some optimization routine in real time to figure out where to send this truck driver. So again, we are bringing this type of advanced analytics to the masses. It's almost like, again, using your iPhone, but to drive very large and complex models behind the scenes. One topic which is close to my heart, and it's not related to large language models, but it's also generative AI, is the area of synthetic data generation. Have you heard about that at all? So what this is all about, well, first of all, you may wonder, well, haven't we heard that we have too much data, people are drowning in data, making sense out of all the data which is generated around the world is almost impossible. Why in the heck are we needing yet another engine which generates data? Well, the answer is most of the data which is generated is useless for modeling. As a modeler, your first job is to clean the data and throw away all the information which you don't need, you may end up with a database, with a data set, which doesn't contain enough information about the question you like to model. So what do I mean by that? Again, I'm talking about fraud as an example. Now, if you want to analyze a database to detect, is there a pattern of a fraudulent detection, where you need to have historic information about fraudulent information. Otherwise, the model will not know what fraudulent means. If your database is full of fraudsters, you are probably out of business because people are taking away money from you. So with this synthetic data, you can generate the data set in any way you like. You can kind of create a table based on real data which is serving your purposes. A nice way to think about this are, the deepfakes images, right? Where you see pictures of people who look very, very real, but we know they don't exist. So how were these pictures generated? Well, they took the attributes of all of us and basically built a new face based on the attributes which we provided. And the same can be done with tabular data, and this is what this is all about. This is kind of an important breakthrough because it will basically allow companies now to say, maybe I don't need to keep all this data, maybe I don't have to store all this data, maybe I can just generate the data when I need it. So this is again very much related to the cloud concept. Alrighty, let's look forward a little bit. Let me lift the curtain a little bit about what are we currently working on. And quantum computing, does that sound like a term you heard before? I guess so, right? NC State, of course, very, very important in the quantum computing research. What we are doing is basically trying to figure out, well, which software can be built which benefits quantum computing. And how this basically will impact us is mostly those areas, drug discovery, financial modeling, simulations, but it's mostly for optimization questions. If you are not familiar necessarily with optimization, how this works, in particular non-linear optimization, let me give you a simple example. This is a very well-known problem in the optimization world. It's called the traveling salesman problem. Of course, it's a toy problem. But in reality, these kind of problems show up in many, many actual business applications. So what you want to find out is, this poor dude needs to travel to all these cities. What is the shortest path he can take to go to all the cities? Does that make sense? With current optimization techniques, what you have to do is you have to fully enumerate all the paths. Because otherwise you will not know what the connections are. And if you imagine that this problem is not 5 cities, but 100 cities, or it's a chip, and you want to design a chip, and you want to figure out, well, how should I put, certain items on that chip? Well, that's exactly that problem, right? So what we can do is we can translate that problem into a so-called nonlinear objective function and start to look for the minimum, right? And the way this works is that you basically iterate through the process, and eventually it will say, hey, I found the minimum. This is the shortest path. Now, like I said, for real-life problems, this can be cumbersome. This can take a long time. And this is where quantum computing will help us tremendously. So we believe that quantum computing will be a similar breakthrough for optimization like the GPU was for deep learning. Okay? So with quantum computing, this algorithm can basically say, look everywhere at once. Right? So you basically go and you find the optimum just like that. Now what we want to do is basically take those findings which the hardware vendors will provide us as a part of our environment, similar to what we do currently with linear algebra. So when you create matrix calculations, you're very much dependent on your chip design. Okay? So this is basically something which we will introduce as a component to our software package so that our users can say, oh, I want to take advantage of quantum computing, and I don't need to think about, well, how do I set up this kind of environments? Second, really important topic. You've all gone through your statistics classes, I suppose. Was it painful? What was the major learning? Well, correlation doesn't equal causality, right? So if something is correlated, it's not necessarily causal, right? Of course, this has been bugging the statistics community for a long, long time, because people will basically say, well, yeah, it's correlated, but it's not really a causal relationship you detected. So they worked on something which is called causal inference, which will now allow software to build models which determine the causal relationship between variables. And again, that's a major breakthrough, because now the software is basically able to explain to you why are things happening. Okay? This is not just, some toy problem. Actually, it was used for the Nobel Prize in Economics in 2021. So the authors basically used this kind of models and received their prize for that. All right. It's getting warm in here, right? So, if all of this excites you and you wonder, well, how can I become a part of this team, this amazing team? I have to say, I'm only here because of them. So we have a development team which largely consists of computer scientists. So contrary to the myth that there are only statisticians over there on SAS campus, it's actually the minority. The majority of people we are hiring are computer scientists, because most of the things which I just talked about doesn't require a statistics degree. It requires a fundamental understanding of computer science, of course. Right? So let me show you a video of an intern.
And welcome to SAS campus.
So what exactly did I do as a year-round intern? So a large part of my day here consists of doing work, attending different meetings. So this is the path I take every day to my office. For me, a big time when I take a mental break, think about the many things to do on my to-do list, and also just get excited for what the day has in store. I worked as an ML/AI intern on the pre-sales team, and so essentially the day-to-day was a ton of coding, creating ML models in 4 different SaaS environments, but then reporting back on user experience to business professionals. As a business and CS major, I really got the best of both worlds. But you think that's good? I got to work on so many other projects. I got to work as a project manager for a Data for Good project, where we were collecting school supplies for teachers in the Wake County school system. But I also got engaged in a day-long hackathon along with all of the other SAS interns, where we won first place. Being an intern is not all about the work. SAS is super supportive and really allows you to find a healthy balance between school and work, especially as a year-round intern. I've met some great people and even some lifelong friends throughout my internship and continue to meet so many more. For me, it's all about the right balance. That's SAS for you. And that's a wrap.
All right, and we recently even got an award for being one of the best companies to educate interns, and it's always a big pleasure for us working with interns because they learn from us, we learn from them, right? It's a win-win situation. So if you are interested in becoming an intern, you either scan this QR code or you talk to those 2 ladies in the back, who are ready to take your questions. You want to just wave real quick, so they are in charge for our intern crowd at SAS. Okay. If you are ready to graduate and you're looking for a first opportunity to, make serious money, here are some of the career opportunities which we are offering. And also we are very fond of hiring early career graduates, people who come in freshly from graduation, who can help us to build the software environment of the future. Okay. With that, 50 minutes of me talking. So now it's up to you to ask questions. And in order to stimulate that, I have some goodies. And the person who will ask a question has a choice. All right. I even have a book, the book which I published. So, yes?
You talked in large part about large language models. Do you plan to incorporate other forms of AI models like video or image models into your workflow?
Okay, so let me repeat that question. So I spent quite some time explaining how we are planning to integrate large language models, and the question is, what about other AI models? The answer is, we do this ourselves. We create all other AI models ourselves, whether it's neural networks, decision trees, gradient boosting, you name it. So we have a dedicated team at SAS who does nothing else but that. Okay? First question, you get the book. How about that? Thank you. All right, other questions? Yes, sir. Okay, so question is, how can we make sure that the large language models are not hallucinating? So this is, of course, ongoing research. What we have done is we are trying to combine large language models with more classical natural language programming questions. So the idea is basically, you know, language is particular. If you are asking a question to the large language model about a certain topic, and I would ask the same question, I would probably use a different type of language, right? So it's the same, we are hoping for the same answer, but the way we are asking the question is different, right? So what we are hoping is basically to introduce a system which will deal with that question and say, hey, these are the same questions. You know, let's engineer a prompt on the fly. And by doing that, we are hoping to reduce the hallucinations as we talk about that. But of course, you know, the world is not yet ready for completely relying on large language models, I will say that, right? So there's still a space for us humans in all of this. All right, what do you want? Cap? Cap is good, all right. Let me see, I can do this. How about that? How about that? All right, any other questions? Yes, sir, in the front.
I think it's more of like a question. When in the video when he was demonstrating how the I guess code commenting works, he mentioned that it uses a RAG system. So I'm just trying to wrap my brain around how like a retrieval augmentation generation system would be used to comment.
For doing that?
Yeah.
That's an excellent question. So the question is, how did we use a RAG system to generate the code? The answer is, I don't know. So this is really up to the programmers. But you know, let me get in touch with the programmers and they can reach out to you. How about that? How about that, Cap? Yes, sir.
So in your response to one of the previous questions, you said that there's still room for us humans. Do you think that AI will be on human level in the near future?
How do you define near future?
Maybe
Next 10 years?
maybe at any time in the future.
At any time in the future? Well, that's a really difficult question. But what I will say is that, you know, people are talking about general AI as a concept, where basically the claim is that the AI becomes as knowledgeable and intelligent as you and me. I think that's not happening in the next couple of years, you know, because if you see that we are just tipping our toe into the waters of AI, you know, so we are at the beginning. I'm a big proponent of human in the loop. You know, I still believe that when it comes to emotions, when it comes to making sense out of difficult questions, you know, where it's about ethics, where it's about bias, where it's about diversity, you know, this is where our societies have been trained for what, 70,000 years, right? So the AI systems are not quite there yet. Now, when you get to my age, will you have to compete with a really clever AI system? Well, that's your problem, right? I will be dead by then, right? So, all right, any other questions? Yes, ma'am. Okay, so the question is, you know, what kind of models do we provide for, let's say, retail? Well, retail is actually full of questions which can be solved by applying analytical model or AI. Inventory problems, pricing problems, supply chain problems. You know, and basically, I've been working with retailers quite a bit, actually. Let me just wave there. So, the challenge with the retailers is that, you know, most of them have been doing this themselves for many, many years. So you come in and you say, hey, I have a model which may do better decisions than you do. What will they tell you? Get out of here, right? You know, what do you know, right? So it's basically a challenging environment. And the proof is in the pudding, of course, right? Once you can show them that your forecasting models are more accurate than what they have done for many years with their gut feeling, well, they may be interested in working with you, and they may say, well, if I can get this greedy, you know, forecasting task to a machine, I can focus on other things, right? And maybe drink more coffee. So talking about that. All right. Do you want to say something to put you on the spot?
I'm here to support you.
Okay.
If there's anything I can say that could be tough, that we'll say related to the retail question, after for some homework, check out the SaaS example of how Ulta is using us. Really exciting, very cool customer example in retail of how they're using SaaS for some of the ways that you do.
Awesome.
The only thing I will add though too though is we've got stickers up a lot.
Yeah, you got stickers. Maybe you just hand out the stickers. And I got the bag, so if anybody has a question, I want the bag. Yes, sir.
How do you see AI generally being monetized?
Monetized?
Yes, we're investing a ton of money in it, but how do we make that profitable for companies?
Like any model, you know, AI is no different. You need to show return on investment. You know, and this is probably the major problem of large language models today. They are freaking expensive, right? Especially when you want to build them, right? So if you're now working on a problem where you're saying, hey, I really want to use this large language model, it's so cool, right? But the outcome is, you know, less profitable than what you spent, you know, then your boss may say, nah, that's not a good idea, right? But in general, I think it's always our task to show how does our work improve the bottom line. Does that make sense? Awesome. All right, so yes.
Where do you get the data that's fed into the large language models?
So like I said, you know, we are basically using pre-trained large language models. So we are working with OpenAI. And that's an excellent question because there is a lot of debate currently going on. How did they actually train the large language model, right? And are they using maybe data which they shouldn't have used? You know, like your papers. Did you ever give them permission to load your papers into the large language model? Maybe not, right? So that's why we as a company try to stay out of that. So SAS is in that regard a more conservative company. Does that make sense? Awesome. No more giveaways, I'm so sorry. Wait, you can give a sticker to her. How about that?
I can be your sticker.
Be my sticker person.
We'll do that.
Maybe time for one more.
Yes, last question. Yes.
Have you guys ever considered for especially models compressing them to a point where you can use them in things like IoT?
Yes, and actually that's an area which I haven't talked about because I had to pick and choose. We are doing this today. We have on-the-edge models. So streaming engines, you know, like Kafka, which you probably heard about. You know, we worked on an approach how we can, as you called it, compress the models. So they are so tiny that they can work on what we call edge devices, and an edge device may be a phone or a sensor. And so the models are executing basically there. An example for that is we did a project with a company which produces solar panels, which you can put on your roof for quality control. So basically, when you produce these solar panels, some of them are corrupted. In the past, there was a person staring at the solar panels trying to figure out, is it cracked, yes or no? Now we are using an image analytics model to do this for us. And that model actually executes in a sensor which is placed above the conveyor belt. So yes, we are doing this today. Well, folks, thank you so much. I hope this was useful. It's getting warm in here, but I will promise I will stick around. So if you have additional questions, just see me, okay?
Right. Thank you very much.